Thank you for those that are logged on so far. We'll get going. Welcome to APAL, one of our first webinar, and with Sean Mason from Agronomy Solutions presenting today. So it's our first one, so take it easy. Any questions? There's the Q&A box there, or any chat, and obviously feel free afterwards to send us an email or call if there's anything further you want to go through. Righto, we'll go just to the next slide, Sean. So we'll just run through today. So we've got just call for topics, obviously, on any future webinars or anything of interest that you would like us to do a bit more work into. I'll run through a pretty quick farm to lab update, really focusing on using it now for sample planning and looking at that spatial variability across the paddocks and across farms. And then Sean's going to follow on from there about some of the latest research in phosphorus applications across the paddock and utilising phosphorus buffering index, the PBI, as a driver, especially as we look at replacement strategies over the years, and then some work on nitrogen around, is it a bank or does it bust, and what happens to nitrogen from year to year.
Might just add there, Sam, a couple of gurus on the soil samplers. Just watch this space for a new sampling rig that APAL's going to deliver on.
That is right, yes. A couple of experts there. All right, so so just on this, so we're keen to keep these as a regular event, but obviously we want to make sure that we're putting out there relevant information. So if there's anything of interest from any of our clients around, and please don't hesitate to probably have a bit of time when Sean's speaking to jot some notes down, or give us an email post this. We want to make sure that we're delivering some value. And alternatively, if there's some stuff, some of the research that Sean will go through, obviously given his location is very South Australian orientated, but we're certainly keen to extend this research and some projects into other states and territories if that's of interest. So make sure that you contact us and keep us in the loop there. Time to lab. All right, so I don't want to make this a software overload demonstration, but certainly just want to some of the changes that we've made to Farm to Lab over the last sort of 12 months, and how you can better utilise it for creating sampling plans and looking across variability. So the first thing to do is obviously make sure that you've got an account. Any data that flows through from APAL that has GPS coordinates automatically goes into your account. And we can upload data from other sources if you've got it. Make sure we've got the settings tab here, so you can go in here and really just set up what you want to view. So sampling distance tolerance is just around if there's 2 sample points within a certain area, then it'll assume it's one or collate them together. So you can change that from sort of minimum of 5 metres up to 50. Depending on the area that you're in, choose your default tests which show up. The bulk density tools there, that we've got a total nitrogen calculator using the nitrate and ammonia numbers plus the bulk density. And we just recently added, we've got 2 pH ranges. So we've got a normal one, which is a standard that comes off our technical reports, and a low range, which can be better used for looking at crop for lime recommendations, I suppose, for soils that are predominantly under 5. So get all those changes suited for your requirements, and then hit the save button, and then you can get into your clients. So I'll just use this client as a demonstration. These are results that we've uploaded from their historical analysis. So pretty simply here, we've got the upload tool. We can upload paddock boundaries. We can now bring in paddock zones to use as a layer to identify whether it is production, soil type driven, to help with zone or with site selection. We can bring in historical soil samples, and we can also bring in historical plant sample analysis. Now there's templates within each to explain which one to bring in. Into the sampling map, and this is client specific. You can see, again, we've got the paddock boundaries in there, all the sites over the years. We turn on the marker labels down here, and we're looking at pH here. So for some of the talk today, we'll focus on PBI. This is giving us good variability, spatial variability across the paddock, identifying trends or areas of concern. Got the legend on the right, which I think some of what Sean might present later might challenge the normal legend here, but we can discuss that later. So this is, we can view it by all years, different depths as well, and then you can drill in paddock specifically. As I mentioned on the zones, if you've got zones loaded, we've got a button here to turn them on or off. So show paddock zones. So you can see this one here is a previous yield zone that's been brought in. So we can sort of work on changing the colours a bit there. And this one here is a nitrogen variable rate map that's been done. All these paddock sites and zones are also available to be viewed in the app. So you can see them as you're actually in the paddock. And then if you're wanting to create, so again, I'm looking at this across my grower or myself, my own farm. Where am I going to sample and why? So it could be simply pH, that I'm wanting to target the low pH areas for this year for sampling only because we've limed, drag them across into your sampling plan, or you're wanting to do some specific paddocks or areas, just right click and drag. Again, PBI you could be just looking at some specifics to get a bit of a gauge on what's happening. So that's how easy that is to do. Again, just using that information that's already there. So what I'm showing here is just analysis. There's some other ways to view sample plans and to create them from historical methods, but we can probably do them more one-on-one with each business. So again, it's going to be pretty quick here, but if you've want some follow-ups with your individual businesses and a demonstration, then just let me know. We finalised the plan. So that's where you want to sample for this upcoming season. Choose your test codes, start a sampling group, and then when you're in the analysis page that I was in, what it does is it gives you why you chose it. So if I was in the pH analysis and I dragged them across, it was because it was low and what year it was. So just a bit of a reference to why you're choosing that location. Again, once you send that to your device, put in your admin details. That plan's then ready, waiting on your phone or on your iPad, Android, ready to be sampled, and then you can utilise those zones if you need to in the paddock to double check, and you can also and then just basically use your mobile device as a barcode scanner, scan them in the field, send them off to the lab. And then we analyse them. Results will go back up to farm to lab again to create a new analysis year, and you also get your email from us as per normal. Just check. So that's sort of again pretty quick and quick overview of this. But really, as we're heading into the summer and looking at sampling strategy for the upcoming seasons or upcoming summer, then this is a good way of looking at that across farm, across paddocks, to really, I suppose, get the most out of your sampling money. Looking at more intensive sampling, targeting soil types or production, and by zones, as opposed to spreading, samples across a large area. So I'll just couple of comments in the chat. No. All right, I'll hand over to Sean now to keep moving on, make host, and get into the phosphorus buffer index work that's been happening.
So I guess, moving on, and it fits in pretty well with what Sam presented on the farm to lab level. So hopefully you agree, pretty neat software, and particularly going into the zonal precision ag in terms of nutrients. So again, you can see the agenda is an N by P focus today, but yeah, happy to obviously for future stuff to look at other nutrients. So I'll probably just start. Some of you might know where APAL Agronomy Solutions are involved in a pretty big project, trying to get more participants in soil, I suppose, soil sampling and participation. So really the project's about building evidence of that practice being economical. So what we've effectively done, the 2020 grab of the soil analysis, so the 213 paddocks in this set, we basically got the growers to identify low production zones and high production zones, soil test, and just see what was driving that production. We also looked at NDVI maps, historical, and also historical grain yields off a paddock level. So I just thought I'd very simplified summary. Obviously, there's a lot of things going on that's going to drive yield on a paddock level, but this is just an example of a paddock in the mid-north. So this project's South Australia, Victorian base, but in-season capture of NDVI of data farming, you can see two zones quite very different, running along the same sowing line, 1 hectare sort of grids that we're using within each zone, and 6 cores for deep ends, and obviously a lot more for topsoil. But primarily what's driving this change was that in the low zone, only 41% of paddocks or zones had a lower end test. So not necessarily end driving that production. That's probably a pretty good indication of efficiency. So the good yielding parts are actually taking up a lot more, well, obviously more nitrogen. But I guess what was interesting, we talk about yield gaps and nitrogen being the cause. Really in these areas sampled, and it is dependent on ecological zones, but 50% of paddocks actually had a lower P test in the low zone compared to the high. So when we start talking about replacement and ground truthing first, it's very important. So yeah, just a real summary of simplified summary of that project outcomes of paddock zoning. So I guess moving on, and phosphorus first, with as Sam mentioned, doing a fair bit of work in South Australia, Victoria, but I reckon I do present a little bit of data, but I think it's quite applicable for other regions, and particularly on a paddock level. I think we possibly have been going about it incorrectly for some paddocks in some areas. So this is research through ourselves and also Trengove Consulting, so Sam Trengove. If you're interested, we're also in GRDC project looking at deep P. So the guys in the north have shown that this is quite an effective method of crops getting deep place P. So we're trialling it in the south, different water dynamics. So if you want to see how that project's going, get in touch with us. And I guess a couple of sort of misnomers, I guess, that I do have a problem with, possibly in the research field, is that as a broad sort of subject and advice is that because we've been applying for phosphorus for so long, our soil P reserves are good, and we very rarely see significant responses to P inputs. I think that's very, very oversimplified. So this, again, just a South Australian snapshot. I could have done it for other areas, but I guess this is all other client data, collaborators basically putting a phosphorus response trial from 2006 and 2012, the black ones you hit and miss with the P response. We are still getting pretty good significant responses. So the y-axis is effectively the yield penalty without applying optimal P. The green ones are sort of trials that we've been involved in and really targeting specific soil types through soil testing and picking up these responses pretty well. So these aren't just small responses, quite often over a ton. So yeah, switching this into an economic, it's pretty important to get your phosphorus right, I guess, is the message here. And there are definitely soil types that we're targeting that we know we've got an issue. So something must be going on here. If we've got a long history of application, but these soils are still responding. They're not virgin sites. These are broadacre, quite good input areas. So this is actually, we're still getting pretty good responses and definitely a gross margin response here with optimal P over a control, so 0P. The other one I sort of want to touch on today is that quite often, if we are struggling with information or don't want to do any soil testing or ground truthing, replacement P strategies are based off grain yields is a good economic strategy to make sure we're at adequate levels. It's possibly not happening in some of these soil tests, soil types, I should say, because we're getting these responses. So I guess replacement P really does work. The industry works off 3 kilograms of P per hectare per tonne of cereal grain yield. That's just a normal number. In the real world, if you did grain analysis off of paddock, quite often, we can get wider than these values, but in the real world, that replacement actually equates to about 2 to 4 tonnes, and it is quite variable across your paddock, as I said. What I really struggle with this management is that we've got no consideration of soil type and its behaviour with P inputs. If you're into any phosphorus chemistry, it's quite detailed, and the fixation of P inputs is quite high for some soil types. So if we sort of eliminate that aspect and don't look at the paddock variability in soil type, which we know is huge, then I think we're doing ourselves a disservice. This, I suppose, just a visual what replacement P looks like in terms of a management strategy. I've picked 4 locations. Hope you can see that. One sort of in the central left there, 2 in the red zone, 3 you might not see, but it's just in that blue zone at the northern part of the paddock, and 4 down at the bottom. So if we were to turn these colours into yields, one sort of sitting in the orange, so 2.5 tonnes per hectare. The replacement P works out, if you're using the 3 kilograms per tonne, 7.5. Go to a poor area, 2 tonne, 6. Go to the best yielding area, which is 3 up the top. We're looking at 10.5. So we're looking at varying replacement P strategies of 6 to 10.5. But I reckon if we're just going in off the top, we haven't done any soil analysis before and trying to interpret these grain yields, I really want to get in and see what's actually driving these low yields. So if we just think, it's a soil constraint, and just keep on putting low inputs on low yields, we're possibly changing the balance in the wrong direction. I think we can actually start helping this production, particularly in phosphorus, with soil types that are picking up in these zones. So just quickly, we talk a lot about PBI coming up. Sam's already mentioned it. We sometimes get the question of what is actually PBI. It is pretty well, it's quite affordable at the lab level. It's quite a simple test. We basically just add a known amount of phosphorus to a soil type, shake it for a period of time and see how much soil removes that solution P over time. So we'll actually take that aliquot after the shaking period and just see what the difference is. So the theory is the larger the difference, the higher your PBI number, and actually reverts back to your soil type can actually bind a lot of solution P when added to it. So it's quite a simple test. And again, there's a lot more things going on at soil level when you add fertilizer to it. But I guess we all know we're all trying to target this soil solution pool in green. That's where the plants can readily access the phosphorus. Unfortunately, in our soil types, a lot of our soil types, the equilibrium and reaction products are driven to the left in this diagram. So your first pool is absorbed P, depending on your soil type. So we can get fertilizer reaction products, a lot of microbial biomass turnover here. So microbial activity will take it up P and then die and release it again. So organic compounds, which I'll speak about a little bit more. Quite often, our soil types actually drive right to the left, and that's where our P bank is sitting. A lot of these fertilizer reaction products are precipitates or strongly complexed phosphorus forms that effectively a lot of plant or crop types are growing can't access. So it does trickle back into the available pool, so back into your on the right, but it does take, we're sort of looking at a decade sort of process, and it takes a lot of time. So this pool definitely doesn't meet annual crop demands. So what we've actually moved, we start seeing variability, and it goes by I suppose by those graphs. We're pretty good at picking up phosphorus deficiencies in South Australia, Victoria, doing work in WA with field trials. We know what soil types we're targeting. So that's very site specific on a paddock, but a project together with Sam, as I mentioned, is actually looking at the variability of responses across the paddock and whether we can actually improve prescriptions, as you call it, maps, and moving really beyond this replacement P concept. So this is just an example of one of Sam's paddocks last year. We've got 5 in total over 2 years, so another 3 paddocks this year, and they're all showing up the same thing. So the numbers just indicate the trial locations. If you're good with the eye, and Google Earth can be quite powerful in picking up vegetation zones and soil type zones, you can see 1 and 2 in lighter vegetation, 3 in darker, and 4 sort of intermediate. So we are starting to see, just by Google Earth, variation across the paddock. So what Sam did was, if you know Sam, he's got a various pH machine, so he's picking up acidic layers, but what he was identifying was poor production in lower pH. So the NDVI map on the left here is effectively 1 and 2 are a poor NDVI in-season vegetation index in 2018. He's done a grid sample with sampling through his Verus. You can see the soil pH, the blue areas actually indicate or line up quite nicely with the red poor areas. So high pH in this mid-north area, it's pretty well given that it's going to be alkaline calcareous. So therefore higher PBI. 3 and 4 actually acidic, slightly acidic, nothing too detrimental. Nothing too detrimental to growth level, so above pH 5 still, but towards that acidic range. So that's a variation you can get on the paddock side of things. People like visuals. This was the in-season growth at the 3 of those locations. So again, site 1 and 2, very highly responsive in season. You can see the comparisons with 0 and 20 for site 1, 0 and 50. And moving on to site 3, you struggle to see an actual response in season, so sort of GS30 mark. So the highlights here are pretty much the PBI on those parts. As I said, alkaline calcareous, 126, 141 is where we're getting these quite significant responses, and not just to 10p. We're looking at responses up to 20p and beyond. Site 3 on the same paddock, 51, quite good. Sort of indicates that P management in the past has been adequate for that portion of the paddock. So gross margin results from this paddock. So GM, so basically the phosphorus rate where we maximise partial gross margins. So where the fertiliser cost wasn't hindering the increase in, I suppose, dollars through increased grain yields. So site 1 and 2, remember, high calcareous, high pH, high PBI. Gross margin P was 36 units, so kilograms per hectare. So that's quite scary for grower, but this does still keep popping up in this region. Site 2 was the worst in terms of PBI, gross margin again, P36. And I suppose just to allocate a green colour to the lower PBI sections, you can see that the gross margins are around typically your replacement P rate. So adequate P management there, just driven by the PBI. So yeah, we thought that was a pretty good indication of the variance of maximising phosphorus inputs, or what is required to maximise growth. Back to, I suppose, you know my history with soil tests, but just looking at Colwell P and looking at grid sampling, I know there are grid samples going around just looking at Colwell P as a layer. I think that's very dangerous. It's well known that you need the PBI interpretation. You can see here clearly by matching 2 of Sam's paddocks last year that we are getting quite a poor correlation with relative yield, so degree of response. So on across a paddock, if we did grid sample this with just Colwell P and not a PBI interpretation, quite low P in the site 1. Site 2 has got a little bit higher Colwell P, but needing a fair bit of P. Site 4, Colwell P alone, data layer does pretty well, 62. You would hope you not get too much of a response there, but it is really the top 2 sites, Colwell P 35 and Colwell P 33. It really is on that single data layer, not explaining that required response or the required P input. So definitely, yeah, hopefully use multiple data layers when looking at this paddock variation aspect on soil type. Some economic numbers around this. So just using this paddock alone, I've just tried to look at the impact of actually getting data lay information on top of replacement P. So moving left to right, you can see the zones, 4 zones. The replacement P rate's basically just looking at where the maximised yield occurred in 2019. So using the 3 kilograms per hectare rule. The PBI again of those zones you can see quite varying. The grain yield based off the response curves, if we use that replacement P rate, you can see there grain yield at soil test recommended P rate. So we're looking at DGT as a calculator with PBI, also Cobalt P with PBI, and you can see zone 1 and 2, the gross margins have jumped up a fair bit. So that's actually looking at P inputs greater than the current replacement P program. So 3 and 4, fine. No need to do anything with management. 1 and 2, you can actually improve that a fair bit. And as you would suspect, this increase in gross margin would be determinant on how much percent of that paddock is under that P deficiency build-up phase or that soil type driving it. So I suppose if you go back and map and you visualize that, the red, orange, potentially yellow might be at a guess 20 or 30% of that paddock. Possibly you guys might be better visualizing that area determinant, but yeah, it really is on a paddock level specific. So I guess Sam talked about what we have historically had in terms of what a PBI value means. So we're talking about the value of PBI. So what does a value mean? Really 0 to 20 in a sweet spot, and also 20 to 70 from what we see. So that index value basically says there's a no or small amount of P fixation. So there's nothing in your soil to really complex and fix up the phosphorus input. So replacement P strategy should work. The P should still stay in the root zone with average rainfall. So that's a win. What we are seeing, probably PBI values of 70 to 100 potentially need monitoring. So the moderate P fixation, so the fixation ability jumps up a bit. We have limited P movement, so the old stratification issue. So I sort of said be alert. Replacement strategies might be undersupplying P, so that whole 3 kilograms per hectare might not be working. And a bit of red, what we are seeing, so where we're getting these sites where optimal Ps are above 20 kilograms per hectare and even more, PBI values are greater than 100. So we're getting this calcareous area or iron complexing or aluminium complexing, which I'll get into a little bit. Yeah, these values really indicate that something's in the soil type to bind applied P. So again, looking at these higher P requirements, it is really important to check your economics and see if you've got the yields to actually make this high P rate pay. Sam's got the farm to lab index there, was based off Phil Moody, so a published table. So we obviously like to interpret off published results. Really, this classification was just to identify or differentiate soil types with PBIs greater than 280. So you can see high is 280 to 840, which is very, very high. So we're talking about in the low range, we're starting to see issues of PBIs above 100, whereas this classification is actually saying it's low. So that's what we're possibly need to tweak, I think, and we can talk about that with farm to lab. Not perfect. I did mention that PBI value. What does it mean? Remember, anything above 100. What we are seeing, there's always an exception. So soils with organic carbon content. So if you remember the whole P reaction diagram before, organic carbon can actually bind P, but it's pretty loosely bound. And I guess, with organic carbon, it indicates pretty good turnover. So some of these soils with 4 or 5% organic carbon can actually have reasonable high PBI values, but they don't behave anything like soil types with a similar PBI that's got the chemistry there. So calcium carbonate, aluminium complexes, iron available to actually bind and fix and precipitate the applied P. So like I said, phosphorus turnover and availability is usually pretty good, and the soil tests reflect that in high organic carbon soils. So not all values fit, which is, I suppose, why we're in the game of soil testing. Very much a South Australian Victoria story. So alkaline calcareous.
Sorry, Sean.
Yep, go Sam.
Yeah, so just if you go back to that one, we are looking at obviously Sean's talked about doing intensive sampling or grid on just Coldwell P, and then now we're looking at, well, we need PBI, we need organic carbon, and we are looking at ways of being able to I suppose turn around some quick testing using the mid-infrared. So mid-infrared, we're getting it to pick up PBI, organic carbon, carbonate, and your soil texture. So come speak to us, but we're looking at having options around using the mid-infrared for sample speed, running a smaller percentage through the lab, but what it's giving you and your clients is obviously more information to make a better decision, and there's plenty of data going through at the moment. The more data that you can put through specifically in your area, sort of the better the models are compared to ours across the whole country. But in saying that, they're still pretty good. So just something to keep in mind that, yes, more information is better, but it doesn't always have to be at, I suppose the higher costs that may become associated with, more intensive sampling at a higher amount of nutrients.
Nice one. So like I was saying, an alkaline calcareous dominated paddock level variability representation previously, but I guess we are tapping in. I did mention work in WA, so replicated trials. This is just a very gross mean grain yield increase with P application in response trials in WA. Broadly, loosely categorised PBI in this case, but I guess again above 80, we are getting these bigger responses. We are getting low soil test values, particularly DGT. We are getting wins there with higher P applications. So we're talking about the 20 to 30. What is, I suppose, the guess is the question would be, what's the variability at the paddock level? Is it, do we need to look at that? And I think Sam had a beautiful case of one of his clients in Farm to Lab. Just the variability here with a site near Merredin, WA. Hopefully your eyes are good. The bottom left part of the paddock, we've actually got values 56, 70, 41, which is not too bad. Northern part of the paddock, which is actually lines up pretty well with that poor growth area. PBI 132, 155. That's definitely not carbonate over there. It'll be the other million complexes over there. Sam talked about, we talked about the classification again, so it's actually green. But I think, we need to look at that definitely as an amber or a red colour to be aware of. So there is definitely variability across the paddock level in WA. New South Wales started to do a bit of work over there. So this is primarily a P availability index using DGT on the x-axis and PBI on the y. There's a pretty good relationship across two paddocks here. Obviously overall levels dependent on P inputs and crop history, but those trends again suggest the higher PBI areas in New South Wales are actually driving lower P availability. So I think there's room to move. So Sam jumped in, but just backing up what he said as MIR as an option, we understand, we talk about intensive sampling and costs can increase quite significantly very quickly. So grid sampling can be expensive if we're looking at this type of detail. MIR is an option, as Sam said, so just building in texture carbonate for the South Australian Vic guys, PBI and organic carbon. So starting to build our own data sets, so client-specific data sets, similar soil types in a particular region is going to be quite powerful. With this example of a client just building their own data set, so quite a good relationship with PBI predicted by MIR with PBI reference in the lab. So I suppose, just quickly finish it off, just wary of time. Nitrogen bank or bust, another farm to lab example here. Hopefully you can see the numbers there, but again, we're seeing this variability in nitrogen profile N. So this is N kilograms per hectare profile across the paddock landscape as well. So I think this zonal does apply to nitrogen. There is a bit of work moving into this area. particularly with the ability of harvesters now to pick up protein and produce protein maps. So this is just possibly not the best representation of what I'm trying to talk about, but a published paper by Jensen looking at protein map, and definitely need to line that up with the yield map to get your overall end story. And I think there's particularly development of zones in the paddocks combining the protein by yield maps. So I need to emphasize that end removal is a function of both yield and grain end content. So just getting a protein map and doing an end replacement off that is I'd use a fair bit of caution. So again, 2 lows better than 1. So as an example here, just pulled out the protein map. On the left-hand side, we've got orange, so 8 to 9% protein, but that corresponds obviously a yield dilution to 3 to 3.5 ton zone. So you actually, when you equate the removal, it's 41 to 54 in that classification, kilograms of end removed. On the other side of the little purple section, we've got protein, pretty good protein, 11 to 12, but corresponding low yields on the right-hand sides in yellow to 2 to 2.5 tons. So very similar end removed, but I think very different 2 stories there of what's actually driving that yield by protein relationship. I think we can start looking at different zones. This is from Ed Scott. So yeah, I quite liked this. So yeah, edited it from him. But yeah, I mean, we can easily start looking at systems and what actually is happening with these 2 ratios. So again, happy to get advice on this and use your own knowledge around nitrogen. But I guess high yield and high protein zone 1 seems like a pretty good and efficient system, high removal. They'll require high inputs. That's what's going to make you money. Zone 2, high yield, low protein, probably suggests there's good potential. There's potentially an mid to late end season limitation, whether that's input or just season soil type or climate driven. What we are starting to pick up is a lot of low yield, high proteins that suggest there's a constraint or potentially seasonal, season cut off. So there's lack of moisture. So the crop's got plenty of N, but just basically didn't finish off with yield. 4th category, low yield, low protein. Effectively, something's going on that we need to investigate, I reckon. So just moving on to probably that zone 3 more, I reckon we can get a lot of information just by doing profile ends across the paddock. This is an overall, again, sorry, the GRDC project in the southern region, but effectively those 2 zones, high production, low productions, the low productions were coming back with higher profile ends as a very overall gross summary. But when you start delving into some of these, what's generating this low production and lower nitrogen use efficiency, there's constraints present. There's also a hand in hand going with these low P zones that we're starting to pick up with low production, in particular NDVI. So just an example of an identification of a constraint. Typical mallee system, sand mid flat, so Jeans Wales system. Typically we get low nitrogen in the sands and mids. In the flat, I guess we've got a 0 to 30 interval here and a 0 to 90. You can see the difference in the flat is a lot bigger between the 2, and there's actually a pool of nitrogen. Could be quite obvious, but we've got a pool of nitrogen sitting there that hasn't been used. There's poor nitrogen use efficiency in this section. So if we're just applying blanket rates of N, we can actually tap into a fair bit of some of this pooling of nitrogen. But yeah, a lot of it is in that 30 to 90 zone that's got high boron and high salt. So the plants aren't getting there, it's not tapping it out. So yeah, we could possibly refine back your N if these are too hard to fix. Nitrogen, again, coming back to say a P story, it could be another nutrient limitation. So this was a mineral N off 2 zones in a northern mallee paddock where we had a nice contrasting P response. So quite adequate P where we had higher production, and lower mineral N. So this suggests a pretty good efficient system. So the crop's actually taking up a fair bit of N. Contrast it to the low production site, which is actually driven by a high PBI zone, lower Colwell when you take into account PBI interpretation, and a low DGT. So there's actually some nitrogen being stored there. Again, blanket rates across the paddock is actually building up because the crop's not utilising it. It's got poor nitrogen use efficiency because we're not adding enough P. As an example, just finish off with a paddock, I suppose a split paddock and getting response curves across two parts of paddock. So this was a BCG trial run last year. Basically a paddock split in two in 2018. So 2017, the paddock had been one and was obviously managed as one. In 2018, it was split. So we had a failed barley, low insight, and a fallow 2018. So even at these two sites on the same paddock that's been split, we've got 10 mils of differentiating rainfall. But essentially, we've got a low insight with the failed barley, 20 kilograms of N, and a high insight, 79 kilos of N. So quite contrasting starting ends. There was nitrogen response curves set up in season, and we're getting very different nitrogen response curves as you would expect in the two very different nitrogen profiles. And we are picking this up with the GRDC project. So low site responded quite nicely, probably to statistically maybe 150, or you could say that 80 is doing a pretty good job. No significant response with the high end site. Protein, same story. Probably need higher, probably that 150 mark to maximise grain protein, and whether you're getting that cost back with the grade prices at the moment. And slight increase with the high end side already, but up to 100 kilos of N applied. I think this is really neat in terms of what we're talking about banks. So if we are worried about what's happened this year, I think potentially, hopefully, a lot have finished off quite well. But I think this is really good to this James Hunt starter. Really good story here that what we have applied in the past, if we haven't utilised it for whatever reason, whether it's seasonal, we can actually cash in on the next year. So might be a surprise to some, and some might have already seen this, but effectively for every unit of applied N applied the previous year, so this example is 2018, we're getting basically 60% of that back as mineral N kilograms per hectare. So that was top dress, so we may actually get even more if we're banding N up front and we had a failed season. So definitely scope to cash in. And if you need more sort of evidence on this, there's Graham Sanders from New South Wales data, basically saying the same or explaining the same scenario of N banks. So produced a nice response curve with wheat in 2017, maximised yields at around that 85 kilos of nitrogen. So anything above that, applied above that, is in excess. So what they did, DPI did, basically go over the same plots next year with canola, no more extra applied N. And you can see there quite a flat response where N has actually been utilised in the previous season, but where we did apply extra, we're getting quite a nice kick in terms of canola. So quite a hungry crop for nitrogen. We are actually cashing in with that 2017 not utilised. It's still coming back and quite economical in terms of gross margin. So I suppose don't be fearful of N applied. If we are doing best practice N applications, it should still be there for next year for whatever reason we haven't cashed in the current year. So hopefully that's a bit of insight to what we're looking at with N&P at the moment. And again, like Sam said, we're happy to answer any questions, or happy to sort of look at our testing suites and looking at this sample variability, definitely, because I think hopefully I've demonstrated it can be very powerful and very important.
Thanks, Sean. Sure, our next bit, but if anyone's got any questions, then there's the Q&A down the bottom. Pop in a question and we'll have a look at it. If we don't get any in the next little bit, then we'll wrap it up and thank everyone for your attendance. I suppose thanks, Sean, for the information. Important that's obviously when you're out sampling and making decisions for your customers that you're maximising the value of your time and the cost of sampling. So ensure that you're getting the full picture to I suppose make the best outcome of the results. We're available anytime, as Sean said. Email us, give us a call afterwards if you want to run through anything. Anything customised from a sampling suite, then just let us know what we can do to suit your requirements. Can't see anything coming through, so I'll thank everyone. Thanks, Sean, again, and look forward to seeing everyone around. Cheers. Thank you.